Welcome to this explainer. Today, we're taking a journey to the absolute weirdest and most violent places in the cosmos. I am so thrilled to guide you through this, because the sheer scale of what we're about to talk about stretches the very limits of human imagination.
So let's jump right in with a question that sounds like pure science fiction, but actually has a terrifyingly real answer. What's the most dangerous object in the universe? You know, when we think of cosmic danger, black holes usually get all the hype. But today, we're focusing on the final, screaming form of matter right before a black hole is actually born. To set our baseline for extreme, think about this. A single sugar cube-sized piece of a neutron star weighs 1 billion tons here on Earth. Let me put that another way. If you gathered up the entire human population, all 8 billion of us, and completely crushed us down, we would fit into a single cubic centimeter of this stuff. Crazy, right? So how does something this impossibly dense even come to exist?
Section 1. Birth of a monster. From supergiant to city-sized core.
Okay, so for millions of years, a massive star fuses elements like hydrogen into helium, right? This creates an outward pressure that fights against the crushing weight of its own gravity. But as the fuel runs out, this timeline accelerates violently. Silicon burns into iron ash in just one single day. And iron is essentially cosmic ash. It can't be fused for energy. So suddenly, that outward pressure completely vanishes. In a mere fraction of a second, gravity wins the battle. The entire weight of the star crashes inward, literally squeezing electrons and protons together to form a solid core of neutrons. Then, over days to weeks, the outer layers bounce off this ultra-dense core, triggering a massive supernova explosion that catapults the outer star into space. What's left behind? A sphere only 25 kilometers wide.
Section 2. The Anatomy of Extreme. Bending the Rules of Physics.
All right, to really wrap our heads around this, imagine packing the mass of 1 million Earths into a space roughly the size of Manhattan. Neutron stars do this by eliminating all the empty space inside atoms. Normal matter, the stuff making up you, me, and the device you're using right now, it's actually over 99.999% empty space, with electrons orbiting its tiny nucleus. If you blew an atom up to be 100 meters across, its nucleus would only be the size of a tiny marble. But inside a neutron star, all of that empty space is violently crushed out of existence. It creates a material called neutronium, which is just a completely solid ball of neutrons crammed shoulder to shoulder with absolutely zero empty space. It's literally like taking the entire mass of Mount Everest and cramming it entirely into a single cup of coffee. It's a density that just completely breaks human comprehension. Because it's so impossibly dense, regular matter is basically a polluted vacuum by comparison. If you were to drop a tiny piece of this neutronium on the ground, it wouldn't just sit there, no way. It would instantly fall straight through the Earth. Now, this incredible density generates an unimaginably powerful gravitational pull. A human standing on the surface would be instantly flattened to an atomic scale by gravity 100 billion times stronger than Earth's. To put that into perspective, if you dropped an object from just 1 meter high on a neutron star, it would accelerate so incredibly fast that it would smash into the surface at 1,500 kilometers per second. And it gets weirder. If we travel deep inside the crust of the star, we find a bizarre state of matter that physicists affectionately call nuclear pasta. Down here, crushed nuclei undergo this microscopic tug-of-war between strong nuclear forces and electric repulsion. The result? They stretch and flatten into incredibly strong sheets and cylinders resembling, lasagna and spaghetti. This nuclear pasta is a quintillion times stronger than steel. It forms massively heavy mountain ranges beneath the surface that are only a few centimeters tall, but they literally weigh as much as the Himalayas. Section 3. Pulsars and magnetars, beacons and magnetic monsters.
As that original star collapses down to just 25 kilometers, it begins to spin incredibly fast, kind of like an ice skater pulling in their arms to spin faster. These rapidly spinning neutron stars blast beams of radiation out of their magnetic poles. Back in 1967, when astronomers led by Jocelyn Bell Burnell first detected these rapid, clock-like radio pulses, they genuinely wondered if intelligent aliens were trying to communicate. The signal was so regular, they even jokingly called it LGM1, for Little Green Men. We now know these are pulsars, sweeping the cosmos like giant cosmic lighthouses.
Now, while all neutron stars are extreme, about 10% of them are born as something even wilder, magnetars. These are the undisputed magnetic champions of the universe. We're talking magnetic fields up to 1 quadrillion times stronger than Earth's. That is a magnetic pull so potent it could literally erase your credit card data from 100,000 miles away. It surrounds the star in a raging matter-antimatter plasma storm because the field is so intense it acts as a giant particle accelerator.
Here's how volatile they are. Because the incredibly dense crust and the magnetic field of a magnetar are locked together, they're in this constant, violent struggle. First, extreme magnetic fields twist and strain the star's crystalline iron crust. Second, the incredible tension eventually causes the crust to snap and shift by just a single centimeter. And third, this tiny little starquake releases 150,000 years of solar energy in a fraction of a second. In fact, in 2004, a massive starquake from a magnetar 50,000 light-years away unleashed a wave of radiation so powerful it physically compressed Earth's magnetic field and ionized our upper atmosphere, just proving their terrifying reach across the galaxy.
Section 4. Collisions and Cosmic Gold, the Ultimate Alchemists.
We've looked at what they do on their own, but what happens when two of these unimaginable forces actually collide? Well, often, neutron stars are locked in a binary orbit. By radiating away energy in the form of gravitational waves, which are actual ripples in the fabric of space-time, their orbits decay. Eventually, orbiting pairs of neutron stars crash into each other in a staggering, cataclysmic merger known as a kilonova. The impact ripples space-time and spews out a massive cloud of heavy nuclei, basically their super-dense, neutron-rich guts. During this explosive kilonova, that heavy, neutron-rich matter falls apart and rapidly reassembles, performing the ultimate cosmic alchemy. These collisions forge the heaviest elements in the universe: gold, platinum, uranium, silver, thorium. Over eons, these elements drift through space, eventually seeding new star systems and planets. So our entire modern technological world, and the very gold sitting in your jewelry box right now, was quite literally forged in the explosive death of two neutron stars.
Section 5. The Strange Matter Threat, the Existential Cosmic Infection.
For our final segment, we kind of have to lower our voices as we venture into the absolute dead center of the star, where the established rules of physics might completely unravel. Deep inside the core, the pressure is so unfathomable that the protons and neutrons themselves might dissolve. They could melt into a fundamental bath of strange quarks, creating a theoretical substance known as strange matter. This is a hypothetical, indestructible state of matter that is perfectly dense and perfectly stable. And because it's the ultimate ideal state of matter, it has a terrifying property. It wants to convert absolutely everything it touches into more of itself.
Let's walk through this hypothetical cosmic nightmare step by step. Step 1, a neutron star collision violently ejects tiny, subatomic droplets of this material, called strangelets. Step 2, a strangelet drifts blindly through the galaxy for billions of years. Step 3, the strangelet collides with a planet or a star. And step 4, it instantly infects normal atoms, converting the entire world into a tiny, hot clump of strange matter. Because it's perfectly stable, it would snowball out of control. It would consume our entire planet from the inside out, making Earth the size of an asteroid. The only way to stop it would be to throw it into a black hole. Now, thankfully, the Earth hasn't been consumed in a wildfire of strangelets in the past few billion years, so the odds are pretty well in our favor. But man, it is an awe-inspiring and slightly terrifying universe out there. Understanding these incredibly extreme objects teaches us about the very dawn of creation, but it also leaves us wondering what other impossible phenomena are lurking out there in the dark. So I'll leave you with this. Are invisible strangelets drifting toward us right now, just waiting to rewrite the physics of our world? Time will tell. Thank you so much for joining me on this explainer, and keep your eyes on the stars.